Today we'll be solving the painter's partition problem, and it is a famous problem and you will see various variants of this problem on internet. So let's first understand what the problem actually is. Here we are given n boards and the length of each board will be part of this array, and we are given painters as well. So let's say these are the boards, and in an array you are given the length of these boards. This is let's say 5, this is 6, and this is 5. So these are the length of the boards, and you are also given number of painters. Let's say you are given 2 painters. Now it is given that each painter takes 1 unit of time to paint 1 unit of board. So any painter will take 4 units of time to paint this board, as its length is 4 units. Similarly, 6 units for this board and 5 units for this board. Now all we have to do is find the minimum time that will be required to paint all the boards using these number of painters. But there is one more condition. Here, any painter can paint only adjacent boards. So it cannot be done like if any painter paints this board, they cannot skip this board in between and paint this board. They can only paint these boards in continuous manner. So if a painter paints this board of length 4, then they cannot jump to this board of length 5. They can paint this board only. And once they paint this board, they can also paint this board. So painting done by the painters are in continuous manner. And now we just have to find the minimum time that is required to paint all these boards with the given number of painters. I will take an example and I hope that will make things more clearer. These are the length of the boards given to us. Let's say there are 2 painters. Now, to state the obvious, to get the minimum time, we have to use all the painters. Now in this case, 2 cases arises. The first painter paints this board of length 10, and the other painter paints this board, these 2 boards of length 20 and 30. Or it is also possible that the first painter paints these 2 boards and the second painter paints this one. Let's see what is the time required in both of these cases. Painter 1 will take 10 units of time here. Second painter will take 50 units of time. And if painter 1 paints both these boards, then that painter will take 30 units of time and 30 units of time in this case as well. So these are the 2 cases. Now what is the time required in this case? Time will be 50 seconds. Time is basically the maximum time taken by any painter. So 50 in this case. So 50 here, and in this case it will be 30. Which is better? Obviously 30. So minimum time taken here is 30. This is all about the problem. If you did not get it, I will advise you to watch it again, the explanation of the problem. Now we will move on to the how to approach this problem. Now let's see how we can approach the solution for this problem. So I have taken this sample values and we need to find the minimum time. Minimum time that will be required to paint all these boards with the given number of painters. So this is what we have to find. Now the most intuitive thing that comes to the mind is applying dynamic programming here. And I remember when I was first solving this problem, I applied dynamic programming. But that has much higher time complexity, and it also requires some extra space for that. But with this method that we'll be discussing, we can do this problem in a much better way and it will be much more elegant. But for that, we need to change our perception a bit. we need to discuss some cases first. Now, just for the time being, ignore the number of painters given to you and think about what is the maximum time that will be required. So maximum time that is required, it is when number of painters equal to 1, and that time will be equal to the sum of the length of the boards, because there is only one painter which will be painting all of this. So time required will be sum of the boards. I will write it down here. This is the maximum time that will be required. And now when will be the minimum time required? That minimum time will be required when number of painters are equal to the number of boards or greater than that. So in this case, if number of painters are 9 or greater than that, then minimum time will be required. And that minimum time will be equal to the maximum of boards. Why is that? Because let's say every painter is painting one board, then the maximum time will be required to paint the largest board among all these. So in this case, 35 will be the minimum time that will be required because it is the maximum length of a board. And therefore, we now have lower bound and upper bound for the time required. Now, since we are having a lower bound and upper bound on time, maybe we can apply binary search here. But in binary search, what we do? We find out the mid index. And depending upon the value at that mid index, we either explore the left hand side of the array or the right hand side of the array. But for that we require a target value, which we don't have in this case. So how can we discard either the left half or the right half so that we can apply binary search here? If you think about it, if we can find out whether we can paint all these boards using this mid time, then we will solve our purpose. Because let's say we have a function which is called possible, and that tells us whether using this mid units of time we can paint all the boards. Let's say it returns true and we can. So in that case we can further explore the lesser values of time. But if it's not the case and we cannot paint all these boards in mid time, maybe we will have to try a value for mid which is greater. So we will discard the left hand side and we will explore this right side of the array further. So I hope it's clear how we can apply binary search here, because we are having our possible answer in between this range. Now all we have to do is figure out a function which can tell us whether we need to explore the right hand side or left hand side, and then we will be done. So for the reference, I will just paste the code here. And this, you can see, is the typical binary search code. We are having initializing our left value or right value and the minimum time. Then we are beginning with the binary search. We are calculating the mid, and then we have defined a function. For the time being, don't bother about the implementation of this function. Let's just assume that we have created such a function which is returning true if it is possible to paint all these boards using these many painters in time mid. And if it is not possible, it is returning false. And in that case, what we are doing, we are discarding this left hand side and we are searching the right side of the array. And whenever it is possible to paint all the boards in the given time, we are updating the value of our variable minimum time with mid. Let's have a dry run here. So this is equal to sum of the array is equal to 187 and maximum of boards equal to 35. We will begin with our binary search. We will calculate the mid value, which will be equal to 35 plus 187 divided by 2. We'll be doing 4 division. It will come out to be 111. So this is our mid value. Then we will pass this mid value in our possible function, and if it is true, we will make the minimum time as mid, which is 111 in this case, and we will update the value of right as mid minus 1, or else we'll be updating the value of left as mid plus 1. Now if we are able to figure out how to define this function possible, then this question is solved, because rest is simple binary search. This is the possible function and what it is actually doing. So it is just trying to assign these boards to the number of painters passed here, and it is figuring out whether it is possible to assign all the boards to these painters using only this much of time. And how it is doing, let's see. So we have used a variable temp. So it is the time taken by a painter at any instance. We are initializing it with 0. Then we are traversing this board from left to right. And if any instance, let's say if value of any board is greater than the time passed, then we'll be returning false. And it is obvious, because in this case, let's say we have passed 111 and value of any board is greater than 111. Let's say it is 120. Then this board alone will take 120 units of time, because one board can be painted by only one painter. So it will alone take 120 units. So we will have to return false in this case. Let's move on to next condition. Then we will see whether the time taken by the current painter, if we assign this board as well to the same painter, then whether the time will increase the maximum time that is allowed. So this is the time taken till now, and we are increasing the time by the length of the current board, and if it is greater than the time assigned, then obviously we will require a new painter to do this job. So we are decreasing the painter by 1, and we are assigning temp as board I, because this current board will be assigned to this painter. Since if this board was assigned to the previous painter, the time was increasing than the maximum time given to us. So we are assigning a new painter for this board, and current time required for this painter will be equal to board I. Then if by assigning this painter, the number of painter becomes 0, that means we have used all the painters for this task and we will have to return false. Let's see if this condition was not true, what would have happened. Then we would have simply assigned this board as well to this same painter. Now this procedure is clear and it will be repeated in loop here. And in the end, if we have not encountered this statement or this statement, we will simply return true. That means it is possible. So in this case, for 111, we can verify it. In this case, let's verify this quickly. So 111 we are having, then we will begin the loop. First element, we will see this 10 is less than 111 that is passed here. So we will move on to this condition next. We are increasing temp by value of 10, and it is not greater than time. Time is equal to 111 here. So we will move on to else condition. That means we are assigning this to the first painter. So for the first painter, temp is till now equal to 10. then I will become 1, and again this is less than the time, so this is condition is false. Moving on to this condition, this again is false. That means we need to assign this board as well to the current painter. Next, this procedure will repeat accordingly. Again, all these values, some of these values is less than 111, so it will be assigned. And if here, this is an important thing. Now, this temp variable has become equal to 99 till this index. Next, if we try to add 99, next if we try to add 35 to 99, it is exceeding the value of 111. So that means we need to explore this loop now. So this condition is becoming true and we are entering this if part. We will assigning a new painter for this. So we will make this temp variable equal to 35, because till now this painter has only one task and number of painters is decreased. So initially we passed the number of painters as there were 4. Now number of painters become 3. Then again the same procedure will be repeated. 35 we will add 28 to it, and still the value is less than 111. So only 2 painters will be required and we will be returning true in this case. So it returned true for it. So we will make a minimum time equal to mid, the time that we just explored, and we will discard the right hand side. If it was 111, we would have discarded the right hand side and we would have continued with the search in this left part. Same procedure will be repeated with the updated values, and in the end we will have our final answer. So our final answer is 54, and let's see what is the distribution in this case, distribution of work to the painters. Sum of this subarray, it is 30, 45, and then if we add for 30 to 45, it is increasing, it is becoming greater than 54. So that means this work was assigned to one painter, and from here onwards a different painter was allocated the work. Then we can add 30 and 24 because it is not greater than 54. And for this, since 35 and 28, it becomes greater than 54. That means this work was assigned to the third painter and this alone was assigned to the fourth painter. 53 units were taken by this fourth painter, 35 units by this, and 54 units by this painter, and 45 units were taken by this painter over here. So this is the distribution of the final work. Before ending the video, let's talk about the time complexity of this problem. So this was a possible function. Now in binary search we know the time complexity is log n is the size of the array. But here the upper bound for the search space is sum of boards. Time complexity will be log of sum of the boards. Let's say B is the array of boards, sum of the boards into what is the time required for this possible function, because at every run we are using this possible function. So time complexity of this possible function is just one iteration of this array of boards, so linear. So if there are n boards, this is the total time complexity of a solution, n into log of sum of b. So with this we end this video here, and if you really like this video, do hit the subscribe button and I will see you in the next one.